Now this is going to be one autonomous system. Let's connect the cables. I'll use anything. Fast Ethernet is okay for me, so I'm using fast Ethernet. Maybe the speed will differ. And then maybe here I will use Gig Ethernet. Here I'll use serial Ethernet. Sorry, serial, not Ethernet. Just to make sure, just to show you that BGP can work on any type of medium. Done. The IP address planning need to be done. So let's say 10.23.0.0/16. Ten dot 25. Ten dot 34. 10.54. Here I will have some other network like 192.168.0. Or I can have some public network to make it more realistic, like 200.20.2.0/24. Between router 1 and 2, we'll decide later. Now, the loopbacks. I'm going to match the loopback IP address with the router name. For example, router 2 will be 2.2.2.2. And now we are going to also take the loopback here. Right. You see, to do IBGP between R2 and R4, we need reachability between R2 and R4. Only then the three-way handshake will happen. For that, I'm going to use OSPF. Zero. And then, okay, let's do up to this one first. I'm going to use Notepad. Starting with router 2.
This is just a question, by the way.
Ask me, please.
Yeah. In the re-exams, the quantity of router is fixed, or it depends?
It is fixed.
Okay.
See, you will have plenty of routers, like 30 routers. But
Okay.
I tell you, all 30 are not going to be involved in one question. See, you will have
Okay.
many questions, many sections. In each
Mm.
section, the number of routers that are going to participate may not be more than, will not be more than like 7 or 8 routers.
Mm.
So various sections are there. When we put all the sections correctly, all the solutions correctly for all sections, then you will have the complete result.
Okay.
So there's going to be plenty of routers, uh, but they're easy to manage because if you understand the question and do, you will know what are the routers involved in this. If you see the topology carefully and question
Mm.
carefully, you will not have much router to configure for each section. Different section, different set of routers you will configure.
Okay. And they give you topology like this,
Yeah, very
or
nicely drawn, very informative, like IP addresses, area number, BGP autonomous system number, EIGRP autonomous system number. If EIGRP is there, IPv6, everything will be very clear in the topology.
okay.
Also, it is mentioned very clearly in the question, both.
Okay. But one does not do anything like physical connections.
Nothing like that.
Okay.
No physical connection, all virtual, remote. Same like what you
Okay.
do in GNS3 is what going to be there.
Okay.
Right, I have put OSPF with the IP address. Let's verify show IP OSPF interface brief. Okay, so this shows that IP addresses are properly configured, interfaces are up. If interfaces are not up, I'll not see this result. Looks good for me. G00 F00 is 25.2, F01 is 23.2. Now moving on to router 3. F01 will be 34.3. F00 will be 23.3. Right, I'm expecting a OSPF adjacency with art. Yeah, it is done. OSPF has come up. Now moving on to router 5. Now router 5 I'm not going to configure now because I want to show you the BGP conversation. If we have 3 and 5, we will not know which way the conversation happens. So let us not enable 5 now. We will only have 3, the transit router between 2 and 4. Now going to 4, and F00 we'll have 34.4, F01, we'll have 54.4. That's it. Okay, one more serial interface is there. Let's finish that interface. Serial 6/0 200.20.2.4 0. And we are not running OSPF on that interface. We are not running OSPF between R4 and R6 because 6 and 4 belong to different organization. Router 4. 4 is ready. I'm expecting a OSPF adjacency with router 3 now. Nice. Okay, what is next? See, 5 we are not going to configure now. Before we configure 5, I want to show you a few things. So I'm not going to do it now. Let's go to router 6 configuration. On router 6, interface loopback 0 IP address is 6.6.6.6. No SPF here needed. Interface serial 6/0. IP address 200.20.2.6. 0. I'm expecting a ping between R6 and R4. Pinging R4 200.20.2.4. I'm able to ping. So now EBGP is what we are going to do first. As I told you earlier, EBGP need to be directly connected. Are they directly connected? Of course. I'm not going to form neighbor using loopback. I'm going to use the 200 subnet IP address to form neighbor between R4 and R6. I'm on R6 now. I'm going to say router BGP. Let us assume, okay, let's take BGP autonomous system as 600, just for example, nothing wrong. And this autonomous system here, we'll take it as 2345. Right now, I'm saying router BGP 600. Accidentally, I made it a 60. Router BGP 600. Oh, it's not allowing me. Why? Because already BGP 60 started running. By giving 600, it is not going to overwrite. It's not going to overwrite it. We have to manually delete it if you don't want 60. So let me delete. Now I'll give 600, it accepts. So only one BGP, only one autonomous system, a router can be a member. You cannot put a router member of multiple autonomous systems. Okay, now next is what we are going to do. We are going to say neighbor 200 see 20.2.4 remote AS 2345. I'm going to say this, all right? But I do not want to hit enter now because I want to show you some live updates. Capture, and I want to show you what they send between to form neighbor. Okay, As of now, nothing. TCP packets, no TCP packets, nothing. No, no. This keep alive is not by BGP. Okay, there is no BGP keep alive. You see, there is no source address, destination address. It's layer 2 communication going on. So as soon as I hit enter, you will see something. IP4 source will come now. You see, BGP will try to. BGP will try to look at this. BGP from router 6 is trying to talk to router 4. Please focus. What is becoming the source address? The source address is the egress interface, isn't it? The egress interface is 222.6. That is what the source address you see here, this one. And the destination address is the neighbor address. If you see the configuration that we made, we said neighbor address is 2.4. That becomes the destination. That becomes the destination. And listen, this one, time to leave, it's only 1. What do you understand from this? Meaning, eBGP neighbors need to be directly connected because the TTL is also only 1. I told you the neighbor should be seen as a connected network in the routing table. Is it shown connected? Show IP route. Of course, it is connected. So if it is connected, TTL1 will be more than enough to form neighbor. TTL1 is more than enough to form neighbor. eBGP neighbors need to be directly connected. 2 things you see. 1, in the routing table, it should be mentioned as connected. 2, the TTL is only 1. For these 2 reasons, eBGP neighbor cannot form neighborship if it is too far away. If it is more than 1 hop, it cannot form neighbor. See, I'm emphasizing on this because when I show you the same Wireshark capture between IBGP, the TTL will be 255. Between IBGP, when a packet is sent, it will be 255. This is eBGP. So you no need to say this is eBGP. It knows how. It compares the autonomous system number and it knows. And look at this, the port number, it uses TCP 179, which means the router is looking for BGP services. You see, the 3-way handshake is not getting over. You see the bracket here. See the bracket, the mouse that I'm moving. It's only 2-way. See, I'm clicking again. See, it's only 2-way. The 3rd way is not happening. The 3-way handshake is not happening. You know why? Because the other router is not configured. This router is not configured. So TCP first handshake comes and the acknowledgement is sent. Boom, finish. This router 4 has not sent any sync packet. Let's capture and see again. You see, router 3 is sending a sync packet. You see sequence number. What's the sequence number? 189. And let me click the next one. See, 189, the response acknowledgement will be 190. But you see, there is no sequence number. Router 4 is not sending any sequence number. Why? Because router 4 is not configured to form neighbor with this router 6. So the 3-way handshake is not getting completed. Sync send, acknowledgement received, but there is no sync. Only reset and acknowledgement happens. You see, REST means what? Reset. The neighborship will not come up unless I finish configuring R4. If you see now, show IP BGP summary, this is where you can see whether the neighbor is established or not. I can see the neighbor has never come. It is idle. It has never come. It is idle. It is looking for some response. No one is responding, so I'm idle. I'm not able to actively negotiate and then get established. I'm idle because I'm talking, he's not responding. I'm talking, R4 is not responding. Again I'm talking, he's not responding. What can I do? So I'll be idle. So it's gone idle. Now let's go to router 4 now. Router BGP 2345 neighbor 200.2. Sorry, 20.2.6 remote AS 600. You see, as soon as I hit enter, the three-way handshake will happen, come successfully. Because router 4 is going to source the packet with 200.20.2.0, which is, sorry, 2.4, which is already configured on router 6 as a neighbor. Okay, this is what configured as a neighbor in router 6. This is what going to be the source address of all router 4 conversation. As a result, the three-way handshake will be successful on either side. And then BGP open message will be sent, BGP updates will be sent, BGP keep alive will be sent, and the establishment happens. Let me hit enter and show you that. Boom. You see, you will start getting packets from 4 as well. That's it. See the keep alive update, all this three-way handshake is over. Let me go and click the TCP three-way handshake. See here. See the bracket. It started from here. The bracket still goes down. You see the line goes down here. Look at my arrow mark that I'm showing. This is what the complete conversation, the BGP has come up. Here is the acknowledgement. So if you see here, this is TCP 179 packet trying to establish three-way handshake, and then if you see after the three-way handshake, the open message, this is BGP's packet, open message is sent between router 6 and router 4, and here you can also see the router ID. I want to show you. We did not give any router ID. It will automatically take the loopback interface as a router ID. You see, router 6 has taken the loopback interface address as a router ID. And this is what called as open message. You see, it is also showing its autonomous system number. It says my autonomous system number is 600. If you take the next packet, it will show you my autonomous system number is 2345. This is from router 4. And you see the hold time. Every 60 seconds, BGP will send keep alive. And if keep alive did not come for 180 seconds, the neighbor will be thrown out, because the hold time is only 180 seconds. So what are the messages that is seen in the open message? So what are the information that is carried in open message? It carries the autonomous system number, it carries the hold timer, it carries the router ID, and the other parameters, they're all optional now. What does it say? It says optional parameters capability, like multi-protocol extension capability. We call it as MPBGP. This is how we do layer 3 VPN, along with MPLS. So it carries all the attributes. That's why BGP is heavy protocol. See how many things it carries. And then if you go down after open message, the keep alive messages are sent every 60 seconds. The keep alive messages are like a heartbeat, right? This is keep alive message. And then go down. You see the update. Updates will have attributes. You see, border gateway protocol update message. Update message is type 2, whereas keep alive is type 4. Open message is type 1. You see the bracket, type 1 open message. Type 4 keep alive. Type 2 update. Now if you see
So
the
please, sorry for
no
interruption.
problem.
What is the meaning of that FF there?
See, it shows the maker. It's Cisco router We are using Cisco router, but we are capturing using what? Some other vendor, no? Wireshark.
Yeah.
Is it Cisco's compatible? Is it Cisco's tool? No, not at all. So it couldn't capture the word Cisco, so it simply put some garbage value, say FFFFFF. You know, so that's okay. Which maker sends the update doesn't matter, but BGP appliance is sending. That is what important. See the attributes. There is no attribute as of now because we did not advertise any network so far. And then the three-way handshake got completed. You see, there's a tick mark now. Everything is working fine. That's the meaning of this tick mark. Okay, now let us go back to look at this. When you go to the router, you can see the neighborship has come with router 6. Earlier on router 6, I was showing you it was idle and it was showing neighbor, but now it shows it is up for last 4 minutes and 31 seconds. And so far, no prefixes received, meaning we did not advertise any network. We simply formed a neighbor. If you advertise like 1 or 2 networks, it will show me how many networks is learned via advertisement. Okay, so eBGP has come up. You can also type this command show IPBGP neighbor, and you will see here established. Router 6 is saying I am forming neighbor with the remote router whose router ID is 4.4.4.4. The neighbor is established. It is up for 5 minutes and 2 seconds. And the keep alives are sent every 60 seconds. The whole time is 180 seconds. You see, the interesting part that I want to show you here is the TTL. For EBGP, the outgoing TTL is on, only on. The same thing is what I showed you in the Wireshark. And you see, the port numbers they use to negotiate. So from this, what I understand is router 6 has initiated the negotiation because it has used the random port number, and the responder was router 4. All right, so this is another command. So 2 commands I have showed you now. Show IPBGP neighbor. It shows a lot of information which is not that friendly. So what you can do is you can simply type this command show IPBGP summary, which I showed you earlier. This very clearly shows that the neighbor is established. If it is not established, it will not show the timer here. And here you will see like active or idle. If you see zeros or some number, which means it is good, the neighbor is up. And you can also see the autonomous system number of the neighbor. So far 11 messages received and 10 messages sent. Okay, now let us move on to IBGP. For IBGP, I would like to sniff somewhere here. I want to stop the sniffing here. And delete or close. Right, we're going to sniff somewhere between router 3 and router 4. In one another training, when I do this second time like this, it crashed. I don't know this time it will work. Let's see. Yeah, it's working. Okay, it's working. You will see some hello packets of OSPF. Look at this. Already we have OSPF running. Every 10-second OSPF will send hello packets. It's a open shortest path first. It's a hello packet. Look at this. Hello packet.
Jay?
Yep.
After you finish this, could you explain this loop once, protocol loop? Maybe in the end, it's okay.
I've not enabled BGP on R4. So I have not enabled IP address on R5. R5 is just for now, nothing doing. We are now going to communicate from R4 to R2. no BGP on R3, you can still establish BGP with R4 and R2, between R4 and R2, without having BGP on R3, because TCP is what the protocol BGP uses. If you can ping 10.23.0.2, then BGP session also possible. Say router BGP 2345, neighbor is 10.23, which is the physical interface of R2, physical interface F01 of R2, 10.23.0.2, remote is the same number. When I put the same number, you will see the TTL will be 255. That's what the first thing that I want to show you. I'm waiting for some packet to come. It will come now. This is OSPF. I don't want to see OSPF. I want to see only the TCP packet, TCP. Okay, you see this TCP packet coming from router 4. All right, coming from router 4. See the egress interface of router 4 is 10.34.0.4. That's what the source, and the destination is the address that we configured as the neighbor, 10.23.0.2. That has become the destination. And if we go down, it's 179 to which the packet is sent. It's a sync packet. And okay, I want to show you TTL before all this. You see, TTL is 255. Whereas for EBGP, the TTL is only 1. Because the EBGP neighbors are expected to be directly connected. IBGP, it's a secure environment. It's your own autonomous system, so you don't have a problem. You are freely sending the packet up to 255 hops it can go. And the neighbor can be anywhere between 1 to 255. That's the meaning of this. Okay, so as usual, the neighbor will not be established because the reset happens. You see, RST means reset. TCP reset is happening. Let us now go and enable BGP on R2. Router BGP 2345, neighbor 10.34.0.4. See, this is exactly the same address from where we were receiving packet. See, we are receiving packet from 10.34. 10.3404. That's what we have to say. Otherwise, the match won't happen, neighborship won't come. We learned these things today. Remote AS is same. Two, three, four, five. Oh, twice I typed. Okay, now we will see three-way handshake. Everything will happen very fast. Updates will come. Open message. Yeah, look at this. Open message, keep alive, update. Everything is fine. And now I'm expecting neighbor. You see, up. Neighbor is up. Show IPBGP summary. Even though the neighbors are not directly connected, it can still establish neighbor. As long as the reachability is there, TCP three-way handshake is possible. If three-way handshake happens successfully, the neighborship will come. Show IPBGP neighbor. I want to show you the TTL. Look at this. Here outgoing TTL is 255. Whereas for EBGP it was only 1. And you see the router ID. Router 2 has learned the router ID of router 4 via the update packets and open message packets. From the open message only it learned. Open message packet would have told the router ID. Let me show you. Open message is the immediate packet after TCP three-way handshake. And if you see the open message, you will see the router ID. They transfer the router ID. They share the router ID. You see, 444. Router 4 is advertising its own route ID. That's how router 2 knows about the route ID. All right. Next is.
So type 1 is open message, is it,
Yeah.
Jay? Or
type 1 is open message. Very correct.
And type 4 is keep alive, is it?
Yeah.